You're not doing these physics demos. Well, it's time to learn. It's time to learn the top 10 best physics demos you're not doing. People love the bright white firework that is burning a magnesium strip, and some like to use it to get higher voltages from their lemon batteries. But what other secrets does it hold? Well, I have covered this plastic sheet with a whole bunch of ultraviolet sensitive beads, and I want to find out if burning magnesium gives off ultraviolet light. From now on, you wear sunglasses when you perform this demonstration. Most people are familiar with the light mill radiometer. You shine light on it and it spins. The tiny air pressure inside changes to a bit higher on the dark side, which pushes it into motion. This happens because the black side heats up faster than the white side. The radiometer is mostly evacuated, which I will prove here by cracking this one open underwater. It is not a full vacuum, however. But what most people don't emphasize is that the radiometer is driven not by light, but by heat. And you can illustrate this by pouring some hot water on top. It begins to spin very quickly. Now, watch this. Cold water. Wait. Now it's spinning backwards. The explanation for this effect is found in the article linked below. Number 3, Twinkling Stars. Why do stars twinkle anyway? Well, have you ever seen light rippling on the bottom of a swimming pool? The light from the stars is also rippling, but not from water. It's from the motion of our atmosphere. Demonstrate this by projecting a constellation through a ripple tank of water. Cause some turbulence in the atmosphere, and there you go, twinkling. What other phenomenon can you explain with this? When light travels underwater, its wavelength changes. N1 lambda 1 equals N2 lambda 2. But how could you prove this? Normally, we can measure the wavelength of light with a ruler and a diffraction grating. Here, at about 40 centimeters away, I am getting a different amount of diffraction for each of my 3 colors. 405 nanometers for violet, 535 nanometers for green, and 650 nanometers for red. Underwater, however, the green laser is seen to spread out much less. I only get about 400 nanometers for green. That's a decrease of 25%. And more importantly, it's consistent with the theory. Number 5, the Barkhausen effect. Is nickel magnetic? I guess it is. The magnetism is formed when tiny little crystals, called domains, grow in the direction of the magnetic field. You can hear the magnetism taking shape if you place the nickel in a coil that's connected to an amplifier. A crackling will be heard as the domains form. Do you hear it? You might own one of these Air-Zuka air cannons. It works by shooting a vortex, which is like a smoke ring, except invisible. Unless you add smoke. Now with smoke in place, we can actually see the vortex ring. Use it to blow out birthday candles or wake sleeping students. Do you already do this demonstration with pulling a rubber band across a box? Changing the tension changes the musical note. This is similar to how a guitar works. On a guitar, the strings are pulled tight in a tension across the sounding board, which vibrates so you can hear them all much louder. But there's a better way to do this demonstration. Take the rubber band and pull it and stick your finger in your ear. Now, the rubber band is going to sound like a bass guitar in your head as the sound goes through your finger into your skull. And the best part is, all of your students can try this at the same time. Superconductivity is already an impressive demonstration. The currents generated do not weaken with time and cause a perfect magnetic repulsion. But what most people don't show is that the superconductor is actually expelling the magnetic fields as the phase change occurs. The magnet gets lifted out. This is called the Meissner effect, the expelling of magnetic fields. The point is, superconductors are not just perfect conductors. They are a completely new phase of matter that expels magnetic fields. For a long time now, I've used white paper as a means by which to find ultraviolet light. Here, we see the lines of the mercury spectrum, and the styrofoam does not fluoresce, so it's good to compare the two and dramatize the situation. I will now use this approach to test out how effective sunblock is. What is sunblock supposed to do? Block ultraviolet light. Here we go. Yes, the white lotion appears dark in the ultraviolet. I hope your students will be convinced that this stuff really works and that they should use it. This concave mega mirror can make a lot of funny images, and it's similar to those used by telescopes to focus light. The focal point is half the radius. You can make this focal point visible by using fog in a can outside on a sunny day. The focus is clearly visible when facing the mirror toward the sun and spraying the fog. Place a bit of dark construction paper at this point, and it will immediately burst into flame.